myself Dr. Preeti Jugwani. I am an associate professor from Department of Computer Science, Aryabhatta College, University of Delhi. So in our previous lecture, we looked into the greedy technique of solving, so many real world problems, which we have seen like activity selection problem, then we have fractional knapsack, then we have coin change problem, and so on and so forth. So today our agenda is going to be our fractional knapsack problem, but before going on to the agenda, let us take a quick recap onto this for this greedy technique. So greedy technique or greedy algorithm, as I have told you, are simple and straightforward, short-sighted in their approach because they are kind of looking for the available best or the we can say local optimal. Kind of they are similar to dynamic programming because they also look forward to looking into this optimal substructure of the problems, and it is also used to solve the optimization problems. Now real life examples of greedy algorithms, if we talk about, so we have seen till this point we have seen activity selection problem, we have also seen Huffman coding, Dijkstra's algorithm, then minimum spanning trees, be it Prim's algorithm or be it Kruskal's algorithm, all these we have seen. And another problem which is a very common problem known as coin change problem is something also which is an example of greedy algorithm. But today's agenda is fractional knapsack problem. So if we talk about fractional knapsack, let us first of all try to understand this problem first. So if I am saying knapsack problem, there are two versions to this knapsack problem. One is fractional knapsack, another one is 0-1 knapsack. Now knapsack is nothing but a bag, right? So knapsack problem, if we say the objective here is to maximize the total value in a knapsack of limited capacity. So we have a bag whose capacity is limited and we want to put some items into it. We want to all those items are having different weights and their value also. We need to maximize the total value which is there in the knapsack, and that should be kind of bounded by the capacity of the knapsack. So for example, a thief is going to break into a particular jewelry shop. Now he is having diamonds, golds, and silver or platinum also with different values and different weights. So let's say gold is available in X weight, Y is the weight of silver, and so on and so forth. Now the thief is carrying a bag with himself. Now what do we want to do? He will try to maximize the total value in his bag by picking up all those items which are having maximum value and kind of we can say maximum value corresponding to their weight, because he is having a bag that is of the limited capacity. Now here when I am talking about the two versions to this knapsack problem, one version is the fractional knapsack problem. Here you are allowed to take fractions of some items. So that means you can pick half of the item, you can pick 3/4 of the 1/3 of the item, and so on and so forth. While if I am talking about the another version which is 0-1 knapsack, in 0-1 knapsack either an item has to be picked or an item has not to be picked. You cannot take the fractions of the item. But here if I am talking about fractional knapsack, you can take fractions of the items, unlike 0-1 knapsack. So this is what fractional knapsack problem is. Now what is going to be our kind of solution, what is going to be our approach? Let us first try to visualize this problem with the help of this figure. So here you can see here is a bag, here is a knapsack whose capacity is 15 kg. So that means we are not going to put, or we cannot put items more than 15 kg. Then there are different items, if you can see, with their value and with their weight. So, let us say there is an item whose value is $2, weight is 2 kgs. Then there is an item with value $1, 1 kg is the weight. Then we have an item having weight 4 kg but value is $10. Similarly, one item for 1 kg with two values with value $2 and one with 12 kgs and value of $4. So, we need to put the items into this bag. We can take fractions of the items, that is allowed. Also, what do we need to do? We need to maximize our value which is bounded and obviously the weight of the item has to be bounded by the capacity of this bag. So, this is what actually our knapsack problem is. And we are going to solve this knapsack problem because we are talking about fractional knapsack problem. So, this fractional knapsack problem can be solved using greedy, while if I am talking about the 0-1 knapsack problem, in which either you need to pick the item or you need to you do not need to pick the item, that can be solved by using dynamic programming. So, two different kind of versions of the problem we can say, and two different solution approaches to it. Now, if we talk about how are we going to kind of coin a solution to this particular fractional knapsack problem using the greedy strategy. So, first of all we need to look for what kind of greedy strategy I am talking about, what is going to be my greedy strategy for this solution, and then how I am going to coin the solution. So, the steps in this could be first of all we need to formalize the problem, we need to formulate the problem. So, here we are having items with weights and values and a knapsack of let us say capacity which is denoted by capital W in general. And what is the objective? The objective is to maximize the total value. Now, what do we need to do next? We need to represent this problem mathematically. That means we need to define some variables, let us say an array of values where the position where the index denotes the item number and value at index I is the value of the ith item and so on and so forth. Similarly, we need to define an array of the variable weight which is having the weights of different items, and also we have a variable W which is nothing but the capacity of the knapsack. And we should not forget that we need all those fractional kind of inclusions are allowed. That means we can take half of the item or some part of the item and so on and so forth, because we are dealing in the fractional knapsack problem. Now, what is going to be the greedy approach to this fractional knapsack problem? First of all, we need to determine a ratio which is a ratio of value by weight. So, value weight ratio we need to calculate, we need to find. Then we need to sort the items by this value weight ratio, and we will be picking the items by that by this order. That means we will be taking the items of maximum value weight first, then the capacity which we are the available capacity will obviously be kind of reduced, and then whatever capacity we are left with, we will pick the next highest item with the next highest ratio. So, we are having a formula or we are having a ratio which is V by W, which is nothing but value by weight, and the items with the highest ratio are to be prioritized. So, for example, we are having a capacity as I have told you as W. So, we are able to pick the first item in full, the second item in full on the basis of first item and second item. That means the item with the highest ratio V by W, then second item we are also taking in full, third we are also taking in full, but fourth we are not able to take full, then we will be picking some kind of fraction of that particular value, that particular item. So, let us try to see this with the help of an example. Now, here let us say we have 3 items, the value and weight of each of the items is given. So, item number 1 is having a value of 60, weight is 10 kg, let us say, or any unit which you are comfortable with. Then item 2 is having 100 value with weight 20. Then item 3, which is having value 120 and weight is 30, while the total capacity of the knapsack is 50. Now, if you want to include all the items in full, is it possible to include here? No, because the weight of item 1 is 10, item 2 is 20 and the item 3 is 30. So, 10 plus 20 plus 30 makes 60, capacity is 50. We cannot include items of 60 kgs into a knapsack of capacity 50. So, what do we do? So, now here what are we going to do? We will be taking a value by weight ratio. Now, what kind of value by weight ratio I am talking about? So, we need to compute this ratio. So, item 1 is having this ratio as 6, item 2 is having this as 5 and item 3 is having this as 4. Now, how it is this? So, 60 divided by 10 for item 1 gives you 6, 100 divided by 20 gives you 5 for item 2, and for item 3 it is 120 divided by 30 which is 4. So, this is the value weight ratio for different items. Now, we are going to prioritize these items on the basis of this value weight ratio. So, item 1 is having this value weight ratio as 6, 2 is having 5 and 3 is having the ratio 4. So, is the priority. So, item 1 we are going to take in complete. So, whenever we are going to take the item 1 in full, whatever, now we need to see what capacity we are left with. So, the weight is 10 for item 1. So, item 1 if taken in full, knapsack capacity remaining is 20. Then on the basis of ratio, value weight ratio, we are going to take item 2 which is having weight 20. Now, 10 plus 20, 30 weight is gone from the total capacity of the knapsack. Now, we are left with the third item. So, we are taking item 1 in full, we are taking item 2 in full also, but item 3 we are not able to take in full because of the capacity limitation. So, we will be taking item 3 only equals to the weight of 20 kgs. So, here we have sorted the item by their value weight ratio. Then we are going to take the item 1 and that is of 10 kg. We are going to take the item 2 that is also of 20 kg, and we are not going to take item 3 in full because that is not the capacity we are left with. So, we will be taking 20 kg of item 3 and the total value what we are going to have is 60 from the item 1, 100 from the item 2 and 80 from the 20 kg of item 3, which is 60 plus 100 plus 80, and that is equals to 240. So, if we see what all we are having in our bag is the first item as full, the second item as full, but the third item only 2 by third, which is 20 kgs. The total weight which we are going to kind of utilize is 10 from the first item, 20 from the second item and 20 from the third item as well. So, 10 plus 20 plus 20 makes 50, which is the final capacity of the knapsack, and total value as I have told you is 60 plus 100 plus 80 from item 1, 2 and 3 respectively, and that is equals to 240. So, in this way we are going to kind of implement this greedy technique for this fractional knapsack problem. Let us see one more problem statement or one more fractional knapsack thing, and then try to find the solution. So, here again we are having 3 items, item 1, item 2 and item 3. The capacity available is the total knapsack capacity is 30, and the value and the weight of different items is the item 1 is having 40 value with weight 4, item 2 is having value 100 with weight 10, item 3 is having value 120 with weight 24, and the knapsack capacity, as I have told you, is 30. So, let us find out the V by W ratio, then sort the items by that ratio. So, here we are going to compute the value by weight for item 1, that is 40 by 4, 10. Then for item 2, that is also 100 by 10, again 10, and item 3, which is 120 by 24, is 5. So, the lowest value by weight ratio is of item 3, while item 1 and item 2 are having the similar one. So, in case of these kinds of tie, you can either you can choose item 2 or you can choose item 1. So, we have seen the sorting if value by weight which we are going to do, then item 1, item 2 followed by item 3. So, which items we are going to take? We are going to take item 1, which is 4 kg, then item 2, which is 10 kg, and only 16 kg of item 3. So, the total value if we talk about is 40, which is coming from item 1, then 100 which is coming from item 2, and 16 kg of item 3 is giving us a value of 80. So, that makes 220 in total. So, and if we talk about the total capacity of the knapsack, so we are within the limits, that means the total capacity of the knapsack is 30. So, we have taken first item as full, second item also as full, and third item again 2 by 3 which is kind of partial. So, the total weight which is kind of occupied is 4 kg by first item, then 10 kg by second item, and 16 kg by the partial of third item, which is 2 by 3 precisely, and this is giving us 4 plus 10 plus 16 which is 30, and total value as I have told you is 40 plus 100 plus 80 which is nothing but 220. So, here what we have done, we have taken a V by W ratio, sorted the items and prioritized the item on the basis of highest this ratio, and whatever we can choose best we will be taking into the fulls, and if we are not left with the kind of we can say appropriate capacity, then we are also ready to take partial items in partial manner, that is also allowed. So, if we look into the pseudocode, we input the values, weight and capacity in the form of variables of value as in the array variable, weight also in the array variable, and then there is a capacity. We will calculate V by W, sort all the items by their V by W, and we need to iterate and fill the knapsack, and final we are whatever we are having is total value, and this whole problem is obviously bounded by the capacity of the knapsack. So, here if you can see here is a Python code snippet which is based on which is for this greedy technique. So, we have taken a def which is fractional knapsack. I am going to give you an overview of this with value, weight and capacity. Then we have taken an index, find out the ratio V by W by using the zip method. Then we have sort these ratios, and then if my weight of I is less than capacity, by increasing the kind of maximum value which is available, decreasing it from the available capacity, we are including that item into the knapsack and returning the value of the knapsack. So, within the boundation of the capacity, we are kind of filling up this knapsack with the most, we can say, most valuable items. So, Python code snippet, or if you want to kind of program this in Python, this becomes very simple for the well known reasons, because so many kind of ready-made functions are available in Python for all these kinds of things. If we talk about what is the time complexity of this whole kind of greedy algorithm, so here we have two activities basically. One is the sorting. Please remember that we have taken V by W and then we have sorted them. In activity selection problem in the previous lecture, we have sorted by their finishing, we have sorted the activities by their finishing times. So, we have sorting which is going to take n log n, that is kind of best we can do in the worst case. Then selection, we are going to select, that means we are going to iterate through that particular kind of array, we can say. So, maximum selection can take order n. So, overall if we are going to add them up, we are going to have complexity of n log n. So, this was basically the time complexity, if we this is what we talked about. Looking into the space complexity, so space complexity, we can say we need to sort the items and we need to kind of store those V by W and so on and so forth. So, order n is the space complexity which is used for storing the items. Now, with reference to, or with in consideration to this particular knapsack problem, if we talk about our what is the limitation of this greedy algorithm here, is this may not give an optimal solution for 0 and 0 1 knapsack. 0 1 knapsack, as I have told you, is a problem where you are not supposed to take the items in fractions. Either you can pick the whole item or you can reject the whole item. Here in the two examples which we have seen, you must have noticed that the item number 1 and 2 we have taken in full, but item number 3 we have not taken in full. We have taken a kind of fraction of it, or we have taken item number 3 partially, but this is not available or this is not allowed in 0 1 knapsack. So, greedy algorithm may not give optimal solution for this 0 1 knapsack. Other problems, if we see what other problems are which are solvable by greedy, we have seen minimum spanning trees, both the methods, Prim's, Kruskal's, then Dijkstra's algorithm for shortest path things, that is also a problem which is solved by greedy. Now, particularly if 0 1 knapsack is being talked about, 0 1 knapsack greedy may fail over there, and the solution for that is we need to implement dynamic programming in order to get the optimal solution of 0 1 knapsack in each and every kind of scenario. Now, knapsack problem, you must be kind of wondering that what are those real world applications of knapsack problem. Here I am not talking about the greedy technique. Using the greedy technique, we are solving knapsack problem, but this knapsack problem, where this is being used, or what are the applications which are related to this knapsack problem. So, resource allocation is one problem, or we can say budget management, or if you are able to kind of look into, let us say, cargo loading. So, we have a truck of a limited capacity and we need to load some items into it. What items are to be chosen, what items are not to be chosen, that solution can be worked out with the help of your greedy algorithm. So, yes, there are real world applications of this knapsack problem in cargo loading and budget management and all that. So, here in this lecture we have looked into the fractional knapsack problem, which allows the partial item inclusion. We have solved those problems using greedy strategy, and we have got the optimal solution. And also we can comment upon that greedy strategy is very efficient and kind of simple to implement. This we have also seen in the two examples which we have considered in this lecture. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.